So we're going to start looking at kinematics in 2D. So we're going to be looking strictly at velocity, displacement, anything that has a direction. So now if we're reading a question, it's not going to say speed. It's going to say what is the magnitude of the velocity. And that's where all they want is the value. They won't say speed anymore. Okay? We're going to be looking at something traveling in a horizontal component and a y component, and our math gets long, and you need to pay attention to where we're at, okay? So if I was to say, let's start here, and I wanted to go to E.E. Oliver, which is up a block and over a block, and then I wanted to go to the old bistro, way over here, and then I needed to come back to what's an equally long walk? The subway. And then I decided that I was going to cross over and go to Pizza Haven, because that's where my friend was working. And then I went a couple more places, stopped and visited some friends, and eventually I ended up over here. Okay, that's my path that I took. Let's go with that. Okay. So when we look at these pieces, this is where we started. This is where we finished. And all we need is the resultant vector from where we started to where we finished, right? The straightest line, or the shortest distance between 2 points, is a straight line. All this other wibbly wobbly pathways in here, they contradict themselves. So when we look at this particular thing here, we can see that we have a, I started and ended the wrong spot. But we can see in here that we have a, if we were to draw this little baby here, we have a triangle. And this part here is what we call the resultant vector. Otherwise known what in math? The hypotenuse. So here's my x component, and here is my y component. Okay? And so when we look at it, what's the easiest way to find the resultant vector? Is to look at a right angle triangle. That's our default. And so the sum of the x and y component is what we call the resultant, the total, or the net. Those are all meaning the same thing. And it's the shortest distance between the starting point and the end point. Because their resultant is at an angle, the direction of the resultant also must include an angle. And I'm going to highlight it. That angle is going to be from where we started. Okay? We're going to call that our angle of direction. The great part is you can have an opposing angle There's always one in every class that likes to find the opposing angle, and that's fine. You just have to make sure you use the direction from that point. Okay, and you'll see what I mean as we get further into it. There are two ways that we can record angles. Always start by drawing your grid lines at the starting point of your vector. So if I walk this way, if I was to draw my starting grid line here, this being north, east, south, and west, just going to extend this line. Okay, this will be my resultant vector. And so the angle that I would be looking at would be this angle. And this is the part where people have a hard time wrapping their brain around it. There are two ways to look at this. This one here, this angle is going this way. It starts from the center and it's going up and to the right. If I look at it and I look at this angle arrow here, this direction from the baseline to that arrow, this is, let's say, 45 degrees north of east, right? Here's east, and if I go north from east 45 degrees, I'm going to hit that line. So this is direction from grid line. We're going to practice this, so don't panic right now. Okay, this is the beauty of you guys having done Math 30 before you get to Physics 20, is that this language is going to be familiar. You may not have a 100% grasp on it, but you will have heard it. Okay? If we look at a Cartesian plane, if we were to look at a Cartesian plane, this is going that way, and I was to tell you that this angle was 36 degrees, we can say that this is 36 degrees. Which way am I going from east? Oh, sorry, Kyle. Is that what you're trying to tell me? Which way am I going from east? North. North of east. Or I can look at this angle here. And what angle would that be? If this angle is 36, what angle is this? $54. How did you figure that out, Kyle? 90 minus 36, because this is a right, whoops. This is a right angle triangle. Okay. If I said 56 degrees, which way do I have to go from north to get to this resultant vector? East. This is east of north. Okay. Let's look at another one. This is north. What if I have something like this, and I tell you that this angle is 15 degrees. What direction are we going? What direction is this vector going? It's going down, which is what? North, east, south, or west? Pick one. Which way? South. Okay, so this is going to be 15 degrees. So from the south line, which way do I have to go to reach that vector? East. I have to go east. East of south. What would this angle be? $75. Do we agree with Kyle? Yeah, 90 minus 15 is 75. So this one would be 75 degrees coming from this grid line. What do I have to go? From east, I have to go south. South of east. When we go slow, it makes sense. But when you're on your own the first couple times, it's confusing, and that's okay. Now, when the cardinal plane was discovered or created, it was created, not discovered, they wrote it a little bit differently. What they would do, and I tend not to give questions in this pattern, but there are some questions that we practice that see this pattern. The value out front is the main grid line. So east is my main direction. And the north is my secondary. I have to move from north, or I have to go like on that grid line. Am I going north? Am I going south to get to that resultant vector? This one here would be, this isn't 56, this is 54. Sorry. This would be north 54 degrees. Still have to write the degrees in there. East. Kyle? Yeah. Meaning that north is my main grid line, and I'm going to go east 54 degrees to get to that resultant vector. Okay? What would I do with 15 east of south? How would I write that? Cameron, do you think? Which is my main grid line? My main grid line is, I'm going east of south, so south is my main grid line. It's the one I want to move from. From that, I'm going to go 15 degrees east. Okay, main grid line, how far am I going, in which direction? Avery, try this one. How would I write it in this format here? What did you say? Oh, east. So, good. Do you have a question, Daniel? Yeah, square, sorry. Okay. This is not as common. You'll see one, maybe two questions in this pattern. The more common way of doing it is 75 degrees south of east, so that it's very clear and distinct, and you're not having to remember, is this the main grid line? Is this the secondary grid line? Okay, it's a lot more clear, but it's a direction. What's going on here? Okay, the next one is if you are a sailor. This might be the one you're more familiar with. This is a navigator's reference. The reference point is north. This is 0. Okay, so on a grid like this, we start at the north axis and we rotate clockwise. Which way does clockwise go? To the left or to the right? To the right. So if we were given theta is going to be 25 degrees, okay, that's the angle we're given. Theta is 25 degrees. In navigator's reference, we would actually start here, which is 0, and we would go this way. And so what would this angle be here? So the bearing, theta bearing, would be, remember, this is 90. So what would the bearing value be? 65 degrees, right? 90 minus 25 equals 65. And so if you told a sailor, go 65 degrees, your bearing is 65 degrees, they are going to start at north and they're going to go 65 degrees. You and I might say that it's 25 degrees north of east, but a sailor will know to go 65 degrees from north to get to that same point. Let's try another one. There's north. And we go oops, sorry, you can't see what I wrote. We're going to go 30 degrees north of west. So that's right here. But what's my theta bearing going to be? I have to start at north and I have to go clockwise until I hit this point here. How many degrees did we travel in this quadrant? No, how many? Well, you're not going to be wrong, but how many in this quadrant? 90. How many degrees in this quadrant? How many degrees in this quadrant? 90. So now we're at 90 plus 90 plus 90 plus we still have to go this 30 degrees. So theta bearing is going to be, Daniel, say it again, 300 degrees. Again, this is not very common, However, if you're a seafaring person, this is all the language you talk in. Okay? Why are we bothering to learn about this information? Because we can use it to find very specific drawings. Or we can use it to find very specific information. We use drawings, oh my word, to use it to find very specific information. So if I drive 3.5 kilometers west before turning and driving 7.8 kilometers north, what's my resultant displacement? In other words, what's this guy here? Okay. We could do it the old-fashioned way. We could go and this one was 3.8. I'm starting backwards. You should always start from your story. Okay. Refocus. There we go. The reason that I'm showing you this, there's two things you need to recognize. We always draw our diagrams and the language is tip to tail. This is a tip and this is a tail. So you start out walking here and you move this way. This is our tip. This is our tail. You always draw a tip to tail. The next motion was then we went north. This is the tail and this is the tip. You always draw tip to tail. Always connect them. And we get more complicated as we move through this unit. So if you can do this piece now, when it's easy on a 90-degree angle, when we start doing this kind of angle, it'll be easy peasy. Okay? So, how do I find this value here? How do I find the hypotenuse of a triangle? Do I want c squared or do I want c? C. So c is equal to the square root of a squared plus b squared. So c would be equal to the square root of 3.8 squared plus, no, 3.5, sorry, 3.5 plus 7.8 squared. So I'm going to have Joyce calculate it, and I'm going to have Princess fact check it. What did you get? 8.549 kilometers. Okay, let's just see. Do we get it if we measure it out? We get 8.56. We get 8.7 if we measure it. I'm just going to write 8.7. So that's just based on thickness of my lines. Okay, when I go back to the question, Princess, how many sig digs are there? 2. 1, 2. 4 is going to have an influence on the 5. My answer will be what would my answer be? 8.5 kilometers. However, it's displacement. So I can then take a protractor and you could measure that angle. I wish I knew where my stuff was. Anybody have a protractor kit on me?
This is a good 11.
Oh. Okay. Oh, won't be able to see it. I gotta turn on the big light for this. Oh, I know. Just gonna. Let's try these questions 1, 2, 4, A and B. Let's try those. We got 10 minutes. What would be the total distances? Question number B. Well, distance, he went 3.5 kilometers west and he went 7.8 kilometers north. So for a total of 11.3 kilometers. We don't worry about positives and negatives in distance because it's the sum of the entire way that they walked. Now here, when we did the calculation, what direction is west, positive or negative? Negative. If I was to go negative 3.5 squared, what kind of number do I end up with? Positive, because a negative and a negative makes a positive. Okay? That's why this becomes important. Writing in north of west, we know it's a negative direction, but we can't show it through a calculation. Let's try these 3 questions. And let's put them up on the board. 1, 2, 4, A, and B. individuals of people, there's 4 things up there to answer.